function operations example 3 wants us to look for a new domain. Now in this situation, they're asking us to add these functions together, which is like kind of asking us to kind of combine domains. It wouldn't matter whether we were adding, subtracting, multiplying, even dividing. We have to find out when these both exist. Where is the overlap? Or where is the intersection? That's the big one. That's actually what it's called. And to do this, I think it makes sense to kind of work from a number line. I'm a big fan of like being visual and seeing the overlap. I mean, it's not too big of an ask to kind of make a little bit of a number line. Number lines are usually centered around 0. And it seems that one of the domains ends at 4, one of the domains ends at -3. And look at those square brackets. That's giving me permission to put a shaded included endpoint. And the domain of the first function, f, is including -3 and 4 and everything in between. And I'm just going to say that this is f of x's domain. And looking for g, g seems to have only round brackets, and it only goes up until 2, where I would draw a open, not included endpoint, and it appears to be pointing to the left forever. And there's my domain for G. And I do this because it makes it as obvious and as user-friendly as possible, because where do they both exist? Where do they overlap? And I do definitely see where they are stacked, where they both share coordinates. And I can kind of use this to my advantage and say, I think, when these graphs are combined, which inevitably means that we have to, intersect the domain. The new domain would be including -3, because they both very much equal -3, and they both go up to 2, but since one of them is open, we can't include 2, and then we get this nice complex domain.